On this first one, we're looking to condense this. We have addition between two logarithms, which means what are we going to do with those arguments? What does addition turn into? Multiplication. So this is going to become log base 8 of 3 times x plus 1. And honestly, I'm okay if you write it like that. You can also, if the parentheses are a bother, you can write our log base 8 of the whole quantity, 3x plus 3, and you can distribute it through. Make sure we're aware that this is not another addition that we're going to condense. Like, that's just a plus inside. This is as far as we can go. Do not try and make it go any further. This is inside the argument. So these are both equally good answers. They're both equally good. They're both totally fine. On this bottom one, what do we need to do down here in order to be able to solve this? Yeah, we need them both to be 3s. I can't do anything when this is a 27. But I can rewrite 27 as 3 cubed. So I can make my bases be the same, so that we have 3 to the 2x minus 3. Once we have those bases the same, I know that those exponents have to be the same. If they equal the same thing, 2x minus 3 has to be the exact same thing as 3 for these to be equal. We can cancel out our bases. So then what do we do down here to figure out what x is? Add 3. I'm going to go sideways because I'm at the bottom. So we have that 2x equals 6. Divide by 2, and we get that x is 3. Lots of 3's in that problem, but that's okay. So today we're going to kind of take these two vibes and combine them together. We are going to be taking logarithms and condensing them, and then solving to get an x equals. So we're going to start actually solving and evaluating these logs. So I'm going to put up our first one. We're going to be given problems like this, which are very, very familiar. They feel a lot like when we would just switch between the forms, because they really, really are very similar to when we're going to switch them between the forms. So when we have logs only on one side of my equal sign, I only have logs on the left here. What we're going to do is we're going to condense it as far as we can go. So I want to take this whole side and condense it. I have subtraction in here. What is the subtraction going to turn into? Division. So this is going to become log base 10 of x over 3 equals 1. That's what we see when we condense. From here, what we're going to use is our BPA log BAP, BAP. And we're going to switch it from logarithmic form to exponential form. So we're going to take that the base of our logarithm becomes the base of our exponential. So that's a 10. What our logarithm equals becomes our power. So this becomes 10 to the first. And it's going to equal the argument, or x over 3. So we're going to condense down to a single log. switch it back into exponential form, and then solve for x. What is 10 to the first? 10. That's just 10. So we have 10 equals x over 3. What can I do to get x by itself? Times 3. So what does our x equal? 30. When we solve, our goal is to get to an x equals. That is our whole goal when we solve. We got to x equals 30, so we got there. So we figured out what x is. Questions on this first one? And I got a bunch of people writing still, so I'm going to leave it here for another few seconds. Most of the problems we're going to be given look like this, where we have logs only on one side. We're condensing and switching forms. We'll get to a couple, one other style problems we have later on today, but most of them they're going to look like this. Okay, so here's our next one. We have log base 2 of x plus log base 2 of 4 equals 3. I'm going to give you a second to write it down. So log base 2 of x plus log base 2 of 4 equals 3. And our first step we're going to do is we're going to condense this. So I need to make this into one log. So when we have addition in between our two logarithms, what's that going to turn into? Multiplication. So this is going to become log base 2 of x times 4. Or I'm just going to write that as 4x. You can write x4. That's fine as well. It doesn't make any difference. It's just best grammar to do the numbers in front of the letters. I can't write x4. It makes my brain itch. From here, we're going to switch this into our exponential form. So I'm going to write it down. So we're going to have our log pap, and it's our b, p, a. So what is our base? 2. What is our power? 3. And it's going to equal 4x. From here, we can solve this. What is 2 to the third? 8. So we have 8 equals 4x. What does x equal? 2. Questions on these as they stand right now? Okay, let's keep going. So they're getting a little more wild now. Got log base 8 of the opposite of x minus log base 8 of 9 equals 1. Again, I only have logs on one side of my equal sign, so all we have to do on this side is condense. So we're going to condense these two together. I have subtraction between them, which means what's going to happen with my arguments? Division. So this is going to become log base 8 of a fraction that has the opposite of x over 9. So our first step is always going to be to condense as much as we can. Then we're going to switch our forms around. What's our base here? 8. What's our power? 1. And our argument is that fraction of the opposite of x over 9. What is 8 to the first? 8. So we have 8 equals our fraction, the opposite of x over 9. What can I do to get x by itself? Multiply both sides by what?
9.
By 9. Let's ask her. There's 2 ways of doing it, and that is absolutely a fine way to do it. I wanted to see what we were thinking. So we have 72 equals the opposite of x. Don't lose track of that opposite. So what does x equal? Negative 72. Sometimes our answers are going to be big numbers. Sometimes our answers are going to be fractions. When we get into things like tomorrow, some of our answers are going to be super gross decimals. And that's okay. Today they should all wind up as at least recognizable numbers, not decimals. We'll have fractions maybe, but not super gross. Okay, so here's our next one. And this one's a little bit different because I have logs on both sides. Thank you, my dear. We have logs on both sides. So we're going to need to be careful here. So we have log base 2 of a quantity 2x minus 5 and log base 2 of x plus 3. We're going to think about this one very, very similar to that problem that we had in the bell work where we solved. Because when our bases are the same, that means my arguments have to be the same. So if I have just logs on either side, you could subtract one from each side, set them, condense them together, and like do the whole rigmarole like we just did. You're going to wind up with a weird looking fraction, but you can do it. Or we can notice that, well, log base 2 of a is equaling log base 2 of a. A different argument, but it's still an argument. These logs aren't making any dang difference. So these logs aren't making any dang difference. So we can just set the two arguments equal to each other. 2x minus 5 equals x plus 3. So if and only if we have just logs on both sides and they have the same base, we can ignore them. They don't make any difference. The arguments have to be the same for those two statements to be the same. So it's very, very, very similar vibe to the bell work one where we had our bases that were the same down here. We made our bases be the same. Here our bases are the same, so we can just ignore them. We can cancel them out. So then all we have to do is to solve this. What do we do to solve this? Add 5 to both sides. Fine start. Plus 5, plus 5. So we're going to have our 2x equals x plus 8. And I already heard from Kamaya that we're going to subtract x next. I heard you. So we've got our x equals 8. So this one looks super duper complicated, but it was actually a two-step equation. We just have to notice that if our logs have the same base and we only have one log on each side, we can cancel them out. And we'll practice that a little bit more here in just a second. All right, we're gonna work another one kind of similar. But this time we have 2 logs on the left and 1 log on the right. And I believe there's one similar to this on the homework, so I wanted to work one like it. When I have logs all around, I still need to condense before I can try and cancel out my logs. So if I have more than 1 log on one side, I still need to condense as my first step. So we still need to condense. I'll give you guys a second to write. So our problem here is log base 5 of 7 plus log base 5 of the quantity x minus 4 equaling log base 5 of 21. So our first step is going to be to condense. So I have addition between my 2 logarithms, which means what am I going to do with my arguments? Multiply them. So we're going to have log base 5 of 7 times x minus 4. And that's equaling log base 5 of 21. Now I have just 1 log on either side. When I have just 1 log on either side, we notice that these 2 arguments have to be the same for these 2 statements to match. So we can set our 2 arguments equal to each other. Most of the time we think of it as canceling out the logs, but we're doing like 3 different actual things, but it's the same vibe. So we get 7x minus 4 equals 21. So for these logarithms to match, these arguments have to match. They have to be the same thing or those 2 statements don't equal each other. So since the bases are the same, we know that these 2 arguments have to match, so we can set them equal to each other. If our bases weren't the same, we couldn't do this, but since they are the same, we can. We will deal with what happens when the bases aren't the same Wednesday and Friday. So what are we going to do here in order to solve this and figure out what x is? Distribute is an excellent option. So we're going to have 7x minus 28 equals 21. Because we distributed that 7. Then what? Add 28. We're going to have 7x equals 49. So what does x equal? 7. So when we have logs on both sides of the equal sign, Houston.
So for that part, could we have simplified before we started signing?
Be more specific. What do you mean?
Like, where it says the log base 5.
Mm-hmm.
Could we have simplified to get 7x minus 28 before we started signing?
You can absolutely do that. You could absolutely distribute here. If you were to distribute here, I'm just going to say make sure you put parentheses around your argument. So log base 5 of the whole 7x minus 28, totally fine. I just recommend these parentheses so that we don't think it's just log of 7x minus 28. Okay? Yeah, that's totally fine. You can absolutely go from here to here. Totally fine. There are many different pathways through. I show you the one that seems to work for most people, but if you take a slightly different pathway, you should. Okay, so we're going to practice a couple of more solving problems. I've got two more for us. One that's got logs on both sides and one that has logs on one side, because we'll see both kinds of problems. So we're going to go back to logs on one side, and we'll go do another logs on two sides so that we can practice both kinds. Because this also has one piece we haven't done yet. We have 2 log base 10 of x plus log base 10 of 4 equaling 2. The first thing we're going to do is condense this left-hand side. I only have logs on one side, so we definitely need to condense. Our first step, no matter which form we're in, needs to be condensed as much as we can. We got to have as few logs as possible. So when we're trying to condense over here, what's the first thing we need to do? Get rid of the coefficient. The coefficient becomes a power. So this 2 is going to come up and make this be an x squared. So we're going to have log base 10 of x squared plus log base 10 of 4 equals 2. That's a 10. It looks like a 16, but it's a 10, I promise. There we go. So then we have to condense again. I still have 2 logs, so we might have to take a couple of steps. I have addition in between my 2 logs, which means what am I doing with my arguments? Multiplying them. So we have log base 10 of x squared times 4, or 4x squared. You can put x squared 4, that's fine. It just makes my brain itch. Equals 2. Now I have just 1 log. Everything's condensed as far as we can go. We're going to switch it around into our exponential form. So our base is what? 10. Our power is 2, and it's going to equal 4x squared. And then we're going to solve this. We're going to try and figure out what x is. So we need to simplify. What is 10 squared? 100. 100 equals 4x squared. Then what? What do I do to get x by itself? Divide by 4. So we're going to have that 25 equals x squared. So what is x going to be? X is going to be 5 or negative 5. So this one has 2 answers, plus or minus 5. Both of them work. So it doesn't happen super frequently where we're going to toss a plus or minus in. That really only happens with squares or fourths, so even exponents. But it's one of those things, especially if you're looking online or at the online version, it'll be grumpy about that, where we have to include both answers. All right, one more problem. last one for the day, is one that looks like this. So we have log base 5 of x plus 2 minus log base 5 of 9 equals log base 5 of 9. What we're going to do is we are going to condense as much as we can. I can't do anything with my logs until I only have one log on each side. That is the most we can have before we can start trying to cancel and solve stuff out. So we have to condense. Condensing is always going to be our first step. So since we are trying to condense and we have subtraction, what are we going to do with our arguments? Subtraction becomes division. So we're going to have log base 5 of a fraction that has on the top x plus 2 and has on the bottom a 9. It's going to equal log base 5 of 9. This is also our last one, guys. I don't think I said that. This is the last one. So now we have logs on both sides. There's only one log, and they have the same base. We love them having the same base. That is the easiest way for this to happen, because I know in order for log base 5 of this chunk to equal log base 5 of this chunk, those two pieces have to be the exact same thing. So I know for those arguments to match, or for the logs to match, the arguments have to match. So x plus 2 over 9 has to equal 9. So when our logs have the same base and we have just one log on each side, we don't need to have the logs anymore. Down here, what do we need to do to get x by itself? Multiply by 9. When in doubt, get rid of our fraction. Multiply by the denominator. So we have that x plus 2 equals 9 times 9, which is 81. So what does x equal? 70-something, 79. Subtract 2 from both sides. Boop. Okay, so we have a couple of different styles of problems that we see on these, which is why I was trying to switch back and forth a few times on there for us, because we're going to see both kinds. Everything today should wind up with either numbers that we can put into a fraction or whole numbers. We're not going to wind up with super duper gross decimals because we don't know how to do things like put them in the calculator yet. That's what we're going to talk about tomorrow. Tomorrow we're going to figure out how to type a log into a calculator because it's picky and weird. So what you guys have is you guys have a little more than 10 minutes where we can finish up homework 8-2. I'm going to pass out all the homeworks that I have so far. Everything in Canvas should be up to date unless we turn stuff in this morning. I think I have one test for somebody left, but not in this class. So that's kind of the vibe. Tomorrow and Wednesday, we're going to work on how to start doing these things in the calculator. Thursday is the SAT, and Friday we'll do some solving with that stuff. So, yeah, we're coming close to the end. Our chapter test is next week. Yeah, next week. Okay, so I'm going to pass out all the things I got. If you got questions on stuff, let me know. But you guys can now do the backside of homework 8-2. I do have a lot of people that are missing an assessment, and for most of us that are missing something, it was the one we did on the last e-learning day, the skills check that was on Canvas. I had a lot of people just not do it. It's a quiz. It's currently sitting as a 0. Do it. Yeah. So make sure you're checking your Canvas grades. They should be matching your Skywards grades. They should be the same thing. So make sure you're double checking Canvas as well as Skyward.